I wish you a wonderful day and welcome to the OXL YouTube channel. In this video we will talk about how we can utilize the Squid filtering and forwarding proxy to transparently filter network traffic that is passing through a central Linux network firewall. Last time we have configured and installed that Squid service, but we only had a HTTP proxy listener. So we could specifically tell applications to use that proxy to forward and send traffic. But that has the drawback that we need to configure those applications to use the proxy. Of course, as administrators, we can roll out that configuration, but it's a little cleaner if we just filter all the network traffic that hits the network firewall. Let's take a look at our demo environment. Here we have the topology. Basically, we have our client servers and devices. Their traffic hits our network firewall, and in the network firewall we are sending that traffic, the HTTP and S traffic in our case, to our proxy service. If the traffic is accepted, then the proxy will connect to the internet target and send the response to the devices, to the clients. On this demo system, I have already set up the firewall and routing for such a transparent proxy setup. I have covered that setup in another video. If you do not already have some experience with Linux firewalls like NFTables that we are using here, I would recommend you to watch our NFTables playlist and get to know the basics before starting with the transparent proxy, because the transparent proxy is a little bit more advanced topic and the configuration can get a little complicated, complex, and therefore you should know the basics. What else do we have to know about with such a transparent proxy setup? We have to know about that Squid is performing some DNS checks in the background. Whenever Squid gets a HTTP or HTTPS request, it checks if the IP, the destination IP that the client uses, is actually contained in the DNS records that the client targets. So it gets the DNS name from the host header or server name identifier and checks if that IP, destination IP, is contained in them. If that does not match, it will drop the connection. Therefore, we need to ensure that the client and the firewall do resolve the host, the DNS record, to the same IPs. Else we get errors and false positives. Thus, we need to implement some DNS caching service. I already have implemented a very basic DNS caching service using systemd resolved, and I have already covered it in a previous video. So if you need to set it up, check out that video. If you're not using a caching server, you can use specific DNS servers. You need to be sure that the client and the firewall use the same DNS servers, but in practice we always run into issues because cloud service providers use such a low TTL for their DNS records that every DNS request almost gets another IP, a different IP. So yeah, that is problematic for that check. You can also not disable the check for HTTPS. Okay, now let's check out the NFTables config for now. We have our config directory here and our test conf. In this test conf we have our firewall components included. Let's take a look at the TProxy example. Just quickly take a look. We we send traffic to our proxy service that comes from private networks and is going towards internet networks, public networks. We are marking the traffic so it gets routed to the proxy service and tell that destination port 80 should use a HTTP listener for Squid and HTTPS should use a HTTPS listener, because we need to use two listeners when using Squid for such a functionality. Okay, now we also need to allow input and output traffic, so traffic to the proxy service and outbound traffic from the proxy service. And that's pretty much it for the basic transparent proxy setup in the firewalling. And now let's also take a quick look at the DNS caching config. We have some DNS servers configured here. We have also destination NAT rules configured here. These destination NAT rules ensure that every DNS query that is passing through our firewall is redirected to our cache. So the complete network gets our cache enforced, yeah, whatever DNS servers the systems have configured. Yeah, then we allow connections to the DNS port of our firewall and also allow our firewall itself to connect to the DNS port, and the actual DNS cache service should also be able to connect to external DNS servers using DNS over TLS and also unencrypted DNS. Okay, yeah, so far so good. Now let's take a look at the Squid config. The Squid config for such a transparent proxy setup is actually pretty simple. We have our HTTP listener here. We can leave it like that. We need to leave just some HTTP listener, because else Squid throws an error. But for now, let's add the two transparent proxy ports. We have one for HTTP traffic and one for HTTPS traffic. The HTTPS one has the same SSL options defined as the HTTP listener last time. And yeah, that's pretty much it. We then have some options for those TProxy listeners defined. First of all, we disable client IP spoofing. Client IP spoofing can be used if we use Squid in a layer 2 setup, layer 2 transparent proxy setup. If we have a layer 2 network and we physically separate it, put the Squid proxy in between of those two physical segments, we can then transparently proxy the traffic between those physical segments, and Squid will perform outbound connections using the client IPs. So it will spoof the client IPs. The host verify strict can be set to off. That's the DNS check I mentioned earlier, but this, as far as I've understood it from the documentation, this is only changing the behavior of the check for HTTP traffic, so you might as well remove it. And if you do not have a local cache, DNS cache set up, you should at least use specific DNS servers. If you have another DNS server up and running in your network, you can of course use those and redirect Squid to those DNS servers. Yeah, I will comment that out because I have the cache set up. So let's reload Squid. And now we should see our listeners. Yes, we have them here. Now, you should also be able to connect to some internet service, HTTP OXLAT. Yes, as we have seen, we have not specified a proxy and the traffic hits the proxy. You can also do that, of course, with HTTPS traffic. See those requests. Of course, the web application firewall of the server denies our access, but the request actually is going to the internet. We can also test it using the Google website. I have added Google AT because Google domains also change very frequently. If we do not use a DNS caching server, we will get a different IP on every DNS lookup, pretty much. So let's perform a HTTPS request to Google, and yes, we have a successful status code. Yes. That's pretty much it with the transparent proxy setup. I hope it was informative. If you have some feedback, some optimization for such a setup, please comment down below. And else, if you have some more complex setups, need support, please feel free to contact us. Else, have a nice day and servus.